Okay, chemical changes. Now, this is important to what we're studying at the moment. This is our core stuff for Year 8. So, what do we need to know? Change stuff. There we go. What are you required to know? You need to know the difference between a chemical and a physical change. You'll need to know that there's evidence that tells us it's happened. And you need to be able to investigate some simple reactions. So how to form compounds. We talked about elements, compounds and mixtures in a previous video. So, physical change. We don't get a new substance, but you may have changed some of the properties. So there's bread has just become toast. It's still essentially bread. It's not reversible, it's not going to become bread again, but you really haven't changed it. It's just a hard piece of bread rather than a soft piece of bread. Whereas with chemical changes, you've caused a chemical reaction to take place, and the properties of the material change. So when you add oxygen and hydrogen together, they're both gases, but they form water. So you've now got a liquid. So there's a chemical change there. These are harder to reverse. Not necessarily impossible, but much more difficult. So you put an electric current through H2O, normally mixed with some acid, and you'll get the hydrogen and oxygen off again. And we might try with that, our voltmeters, if we can do that in class if we get time. So, what is a chemical reaction? You probably need some terms. There's always lots of new words and science, isn't there? Substances that react together we call the reactants. So carbon and oxygen would be our reactants. The substance they produce, carbon dioxide, will be our product. Not all elements react easily with other elements. We'll talk about that when we talk about the periodic table. We have things called noble gases, and they don't tend to react terribly easily. They can be made to, but they don't choose to. So how do I know a chemical reaction has taken place? We look for a few things. We look for production of a gas. Now that can be just through bubbling. You see things bubbling up. Clearly you've got some sort of gas trying to escape. But sometimes the gas just comes off without you seeing it. So you've got to collect it and sort of test for it. There's a famous pop test. And if it's hydrogen, it'll explode with a nice little pop. If it's carbon dioxide, it'll put your flame out. And if it's oxygen, you'll get your flame to burn more brightly. So you can sort of test which of those three most common gases that something is. You might get light and heat. Plenty of light and heat in that thermonuclear reaction there, isn't there? You might get a change of mass. You might get more mass or less mass. You may get a change in colour. Or you might form a precipitate. So one of the ones I used to love doing was lead nitrate and silver nitrate, and lead iodide, yeah. And you mix them together, two clear liquids, and you end up with a yellow substance at the bottom of a beaker with with some clear liquid above. So I formed a precipitate. So the precipitate was lead nitrate. Yeah. Anyway, I can't think of details now. Not allowed to do it anymore. Apparently there's something dangerous of it. Stunning little experiment to show chemical reactions though. So we talked about compounds recently in a video on elements, compounds and mixtures. So when elements join together as a result of a chemical reaction, we form these things we call compounds. So the oxygen you breathe and nitrogen you breathe in all the time, these are compounds of an element. There's two atoms there making that molecule. Lots of words, sorry. So a molecule is the smallest piece, the smallest example of a compound. Clearly when you breathe in oxygen, you're not breathing in one molecule like that, you're breathing in lots of them. This is a molecule of water, which is also a compound, H2O. Nitrogen, we breathe lots of nitrogen in because most of the atmosphere is made of nitrogen. And if two nitrogens join together, but you can also get a thing called nitrogen dioxide, one nitrogen joined to two oxygens. So they have these formulas, and the formulas are really important. That tells us we've got a compound, not a mixture. Okay, another short one. Keep them short.